Assalamualaikum warahmatullahi wabarakatuh, and a very good morning I wish to ZOLKARNAIN, our lecturer. So my name is NORSABRINA binti AZLAN, and I will be the first presenter for today's presentation. Okay, so my group is Group 5, which will be presenting our project, which is steering knuckle. So in this first slide, this is my group members, which consist of 4 people, including me. Okay, first and foremost, let me introduce a little bit about the application that we're using in creating the product, which is CATIA. So CATIA stands for Computer-Aided Three-Dimensional Interactive Application. So it's much more than a CAD software package. CAD, which stands for Computer-Aided Design. It's a full software suite which incorporates CAD and CAE. CAE, which stands for Computer-Aided Engineering. So, what is CAD? CAD, Computer-Aided Design, is most employed by engineers to help create, modify, or analyze graphical representations of a product design. Its applications stretch across a multitude of industries due to its many popular benefits. So, CAD software innovation continues to improve the quality of a design through greater accuracy and the reduction of design errors. CAD software is also capable of improving communication, which is one engineer to another when they're explaining about a project design. And due to the centralization of design data and documentation, it's creating a single source of truth for engineers and manufacturers. Okay, in this section, let me introduce to you a little bit about our project design, which is a steering knuckle. So what is a steering knuckle? The steering knuckle is the pivot point of the steering system, which allows the wheels to turn. On cars with conventional suspension systems, the steering knuckle spindle locates and supports the inner and outer wheel bearings. The steering knuckle is a big chunky piece of steel with several protruding arms located right behind your left and right front wheels. It's connected the wheel hub or spindle to the suspension. The disc brake caliper is also mounted to the knuckle. Also known as a wheel carrier or an upright, the steering knuckle is the last part in the steering system. There's one steering knuckle attached to each left and right front wheels, and it's supposed to turn your wheel when you steer. Last but not least, the objective of this mini project is first to enrich students' skill and knowledge to the application of AI and CAD/CAM software for CAM presentations. Secondly, able to construct basic principle CAD/CAM methodology into 2D and 3D surface. Third, design a precise 3D mechanical parts with an intuitive and flexible user interface, from sketching in an assembly context to interactive detailed design. And last but not least, able to manipulate machining strategies and using the right toolpath method for milling or turning operation for a given part. So that is all for me today. I will pass to the next presenter for the next slide.
Hi, my name is MUHAMAD HAKIMI. I will continue the presentation with project planning. Project planning has been divided into 2 sections, which is Gantt chart and task allocation. For the Gantt chart is a project management tool that is often used to simplify and manage team members' workflow for the duration of the project. It creates a visual representation of all the tasks assigned to the respective team member, a specific timeline, and delivery dates for each of them. The diagram below shows the Gantt chart. Our process started with the proposal of project and then continue with selection of the part, project report planning, and then we having a break, midterm break, which is Hari Raya Puasa, and then continue to project report, which is performing, and then video making for the last day we'll have the last check and then submission. Next, for the task allocation. Task allocation is the way of working process organization when responsibilities and workloads relate to one task are distributed among different individual and organization unit that perform on part or portion of work common. The diagram is the table below shows the tasks and the members. For the proposal will be held by NORSABRINA. Then in the project report for the introduction will be Sabrina also. Then project planning is me. 3D modeling will back to NORSABRINA. Process planning is me. Cam and machining is SIVANESWARAN. Result, discussion, conclusion and video compiler will be Nurain FIRZANA.
My name is SIVANESWARAN MANOKARAN from BMMP 1/2. Today I want to start from 3D modeling. Okay, what is the 3D modeling? AutoCAD 3D modeling allows us to create drawing using solid surface and mesh object. Solid surface and mesh object offer different functions than when used together offer. Okay, here is the Knuckle, our project. Okay, I want to explain further in another video. Machining.
Now I will present to you the process planning. Process planning is also called manufacturing planning, material processing, process engineering and machine routine. It is the act of preparing detailed work instruction to produce a part. It is a complete description of specific stage in the production process. For all the process that has been held in the project, we're using the CATIA V5R19 software. So the diagram shows the process planning. We started with the 3D modeling, then make a stock, insert AC system, make a plane system which is 10, 30 and 100, and then facing. After that, roughing and profile contouring. After that, we continue with roughing, but for the bottom side and profile contouring for the bottom side.
It's very complex, and then we have the 3 AC system here panel. Okay, and then WPC here, WPC2 here. Okay, I do the roughing product first. Okay, I rough the up here. Okay, I want to show you. Okay, this is the product I do all. Okay, I want to show you especially isoparametric machining. Okay, isoparametric machining. Okay, isoparametric machining is the setting like this. Okay, machining. Okay, this is show the this part. Okay, 1, 2, 3, 4. Okay, wait, I remove the stop first. Okay, you can see more detail. Okay, you can see. Yeah, okay, yeah, and then point, and then the this will cut like this. Okay, like this. Okay, and then I want to show the final simulation of our product. All the service I think you got ready. I think you can do by own self, but this product I cannot settle by my own self, and then if some much of the problem I cannot solve it. So I'm sorry sir, I cannot solve it the problem all. Okay, we simulate this and then I can show you 1 minute 45 seconds. Okay, this is the roughing. Okay, I solve the roughing first in front. Okay, faster. Okay, you see this side. Okay, you can see this side cannot the tool go on, and then this surface also to the tool cannot go on, and then I can also didn't enter from this plane, from the right to left, so I cannot cut the contouring part. If I cut also, they will spoil my part, and then they cannot show my the part like real lah. So I also cannot finish this works like cannot do the solve all the problem. Okay, like this. This is the behind roughing. My PC was weak. Okay, behind roughing. Okay, and then the old part. Okay, this is my final project. I have some problem and I cannot solve it. I'm sorry, sir. Okay, thank you. Statement. I have much of the problem when doing the part. The part was very complex. We try a lot of error process. Although using small cutting tool cannot cut interpret in a surface. The plane system perpendicular also not support to cut the product properly. Take a lot of time to test tool that okay with the surface. Much of surface when try cut tool cut another also.
Assalamualaikum, my name is Nurain FIRZANA. I will present about the discussions of our project. All comments that generated is through computer-aided design and computer-aided manufacturing. The product in this mini project, which is steering knuckle that produced by all of the comments stated in these sections, which is pad, pocket, edge, fillet, hole, and slots are the comments for the CAD. While for the CAM is advanced machining, part design, roughing, profile contouring, parametric, spot drilling, then drilling deep hole, and also machining access change. The techniques and difficulties to draw, model, and simulate the steering knuckle is stated, and the ideas to improve the machining of steering knuckle will also further discussed in this chapter. We find out that the most difficult part in this mini project is the simulations, advanced machinings of the steering knuckles. In this process, the profile contouring of the steering knuckle need to be selected accordingly. If there is one step wrong, the part design will be failed to be formed. The distance between the pad and the number of pads need to be set accurately. Otherwise, the machining process will not perform smoothly. Based on this project, it finds out that the final finishing machining of steering knuckle was roughly surface. To solve this problem, it can be used ball nose and mill instead of end mill tools. Ball nose and mills are used on workpiece with complex surface, but the disadvantage of using ball nose and mill tool is it takes time so slow for the machining process. It is important to acknowledge on what tools that will be chosen. End mill tools are often used for roughing process and 2D cutting and BVB, while the ball nose cutters are often used for finishing operations. So, the conclusions and the recommendation for this project, which are the student able to learn on how to develop basic principle of CAD/CAM methodology into 2D and 3D. The student able to understand on how to develop basic machining operations such as profile operations, roughing operations, and so on throughout this project. The student will acknowledge on how to construct and set up tool operations such as machining parameters, simulations methodologies, and anti-code generation for component machining. As recommendations, engineering analysis and design alternative can be used to improve this project. in terms of the quality of the design and the performance of the final product. The design can be then be improved by putting more practice and improving simulation talents throughout precise and standardized engineering drawings. The design documentation can be improved too. Thank you from me.
Thank you for listening. So, if you have any questions, feel free to ask, and we will be glad to answer them as detailed as we can.